So for this problem, we're finding the osmotic pressure at 65 degrees of an aqueous solution containing 2.5 grams of sucrose per 205 milliliters of solution. So the formula for osmotic pressure is given by pi equals I mRT. So the I stands for the number of ions that are formed when a certain compound dissociates into water. M is the molarity, R is the constant 0.0821, T is the temperature in Kelvin. So we have the temperature, but we have to convert it to Kelvin, which just means that we have to add 273. So 65 plus 273 is 338. Now, since this is sucrose, the number of ions that will result from dissociation is just 1, so we can kind of ignore that. The gas constant is 0.0821. Now to find molarity, it's moles per liter. So we have the number of grams and we have milliliters, which we can convert to moles and liters respectively. So 2.5 grams times however many grams per 1 mole sucrose is. So we're just going to find the molar mass really quick. 12.01 times 12, because there are 12 carbons and 12.01 is the mass for carbon. We need to add 22 hydrogens. Each of them are 1.008 grams. That will be times 22. And then finally we need to add 11 oxygens, which are each 16. So that gives us a molar mass of 342.296. So the resulting moles will be 2.5 divided by this number. This will get us 7.3 times 10 to the negative third, and this is moles of sucrose. Okay, now to convert 205 milliliters to liters, we just divide it by 1,000 because there are 1,000 milliliters in 1 liter, and we get 0.205 liters. So then to find molarity, we divide the moles, 7.3 times 10 to the negative third, divided by 0.205 liters. And that will get us 0.0356 molarity. Okay, so now we have to multiply all of our factors together to get osmotic pressure. So we will multiply this molarity, pi equals 0.0356 times R, which is this constant, 0.0821 times the temperature in Kelvin, which we calculated, is 338. And all of those multiplied together, 0.0356 times 0.0821 times 338. This gives us 0.98789, or 0.989. This would be your osmotic pressure.